Hello everyone, it's Benny, and welcome back to the 3D game programming tutorial series. Today is the big day. Today, we are going to be doing our first bit of game development work for the series. We're going to start laying the foundation for the game we end up making. And that's actually really cool, so I just want to go ahead and get into it. Let's go. So, our first task in building a game is very simple. What does it take to make a game? And this is actually really important because this will give us our big roadmap, our big general picture of this is what needs to be done before we get a game. And that's really important to have because once we have the big picture in place, if that is solid and locked down and really accurate for what we need to make a game, then that frees us up to be creative. With all the smaller stuff, with all the details, we can explore however we like. We can try crazy, ridiculous things and still be confident at the end of the day we're going to end up with an awesome working game because we know what the path looks like. We know where to go to get the final game, even if we want to take some creative tangents, right? That's the general idea. So, how do we get this big roadmap? And the way we're going to get this big roadmap is we're going to look at a few different types of 3D games you can make. Just a few genres, because that is going to spell out pretty quickly the general picture of what we're going to need to do, regardless of what type of game we ultimately end up making. Right? So that's the idea. Let's do it. Now, for building this big picture, the first type of game we're going to look at is a space shooter. Why? Well, really, it's an arbitrary choice in some sense. We could start with pretty much anything and end up with the same result we're going to get. But I've chosen this one because it's a logical starting point. It is, mechanically speaking, pretty close to the simplest 3D game you can make that's still reasonably worth playing. So that is why we're choosing to start with a space shooter. And we're just going to take a look at what it would take to make a space shooter. Pretend for a moment we are actually making a space shooter. Will we actually make a space shooter? I don't know. We're going to make something. But for now, let's just pretend so that we can get our heads around what it would take to make something like this. So if we're making a space shooter, obviously we need the player, which is typically some type of spaceship. Does it have to be a spaceship? Not really. I mean, think about the genre. If you replaced the spaceship with, say, an eggplant, just had a flying eggplant flying around, same effect. Really, the critical detail is something moving in 3D space. It doesn't necessarily have to be a spaceship. So that's an important thing to note, because it gives us room for creativity. Immediately, we are not locked into the idea of it has to be something outer spacey. That's good. That's creative freedom. More creative freedom typically means more possibilities of successful games. So, we have a spaceship. Cool. We're pretending it's a spaceship. It's a player. We can control it. We can fly around 3D space. So what? The next thing we need is an enemy of some sort. It's some enemy ship, it's an enemy eggplant, it's an enemy something. Something else that can fly around in 3D space that is not us. And of course, for it to be a threatening enemy, it's going to have to do something. And that doing something means shooting something at us. Whether they be laser balls, whether they be anything. It doesn't matter what they're shooting. Again, room for creative freedom here. But they need to shoot something at us that the player does not want to be hit by. Because that's really the basis of how this genre can possibly be fun. You're generally avoiding some enemy fire of some sort, while at the same time trying to shoot down the enemy with your own fire of some sort. Again, doesn't necessarily have to be lasers, typically is, but that's another area of creative freedom. So the essence of this genre is the player can move freely through 3D space. There's enemies that also move freely through 3D space. They both fire projectiles at each other, and the goal is to hit the other enemy with the projectiles without getting hit yourself. That's the basic essence of a space shooter. I hope that makes sense. I mean, it should. So, now that we have our head around what it takes to make a space shooter, and where we do and do not have room for creative freedom, we can lock down what we absolutely need, what we need to make the basic mechanics, excluding the areas where we have room to be creative. What are the key important things we need to do this? So, in order to do this, a big thing is, of course, rendering. We need some form of render pipeline to be able to draw the player and the projectiles and the enemies. There's really not a lot of way around that. You need some way of seeing what's going on screen, or it's pretty useless, right? So that's the big obvious one. Number one is some sort of motion integration. Things need to move around. So we need some way of integrating motion over time. Just to be clear, by integration here, I'm referring to the concept in calculus, where, motion causes things actually move over time. We can say, hey, this object's moving at this speed, or with this acceleration, and it actually moves with that speed and acceleration. And that's how our ships will move around, that's how the projectiles will move around, etc. Of course, if they just move around, that doesn't mean a lot if there isn't any collision. We need a way to detect, hey, this projectile hit the enemy, or this projectile hit the player, or the player and enemy have run into each other, and some way to resolve that in a way that means something for this game. The player's ball hits the enemy, obviously, enemy takes damage, or is destroyed, or whatever we program it to do. Something the enemy does not like. So that's the gist of that. We need that of some form. And honestly, that pretty much implements the core mechanics. The only other thing we really need is some form of, quote, AI, so the enemy will fly around and attack the player back. And really, once you have all that, that's all the core mechanics we covered. That's the player moving around with motion integration, that's the projectiles interacting with each other. Get those high-level concepts in place, you can build a space shooter. Everything else, you can pretty much have all the creative freedom you want to make it your own unique twist on this type of game, assuming you're doing that. So that's what it would take to make a space shooter. So with that, now we're going to put space shooters to the side. We know what it takes to make that. That gives us a general outline if we want to make that. But what if we don't want to do that? What if we want to make a different type of game? Let's look at a different style of game, like say a first-person shooter, and we're going to do the same sort of process. And from there, we'll be able to get, hey, this is what it takes to make a first-person shooter, and we can start getting a general idea of what it takes to make a game in general, regardless of whether it's a space shooter or first-person shooter or anything else. So what do I need to make a first-person shooter? Well, first-person shooters are a little bit different, because unlike a space shooter, it's not all centered around just various objects in arbitrary 3D space. There's usually some form of level or area where everything takes place in. It could be a simple room like this, it could be a sprawling battlefield, it could be a cave system, but it's usually some area with non-trivial geometry. And that typically offers a few tactical advantages and tactical things for the players to play around with, and can make the game a little bit more interesting, assuming it's done well. So, this is the first key element that's different from the space shooter. Beyond that, the mechanics are somewhat similar. We have enemies, we have our little stick figure dude with crazy hair and a pistol, he's coming right for us. Well, what do? Well, of course, as stick figure extraordinaires, we whip out our own stick figure guns and we blast them. And that's pretty much the essence of a first-person shooter. So, very similar, still have a player, still have enemies, they're still shooting at each other, though in this case, it's not necessarily shooting projectiles anymore. Because, if you have guns, you're doing some sort of hit scan. Basically, is this enemy along the line of gunfire? You usually don't simulate individual bullets moving at their speeds, you usually simulate just, are they along the line of fire? If so, cool, for all intents and purposes, they're hit. So what do we need for this? Like with a space shooter, we will need a render pipeline. We need some way to draw all this, or it doesn't really do anything. We're still going to need motion integration. Maybe not so much for projectiles this time, but we need some way for the player and enemy to move around. You could possibly get away with not doing motion integration, maybe, if you want to do some clever tricks, but your life's going to be easier if you just go ahead and have that in there. And you will still need collision detection and resolution. A little bit different than in the space shooter, because you're probably doing hit scans, assuming typical guns. But if you're not doing typical guns, maybe projectiles are more appropriate. Maybe you're still going to have projectiles bouncing around in this area. And, of course, with enemies, you will need some AI. Even if you're making a multiplayer first-person shooter, where presumably you're shooting at other players, not some fake enemy type, you still want some AI for bots. So you need AI of some sort to make enemies shoot back at you. And really, once you have that, that's the essence of a first-person shooter. You can, of course, be creative with it. You can add in your own twists and takes on the genre. You can make interesting new areas, interesting weapons. You can make possibly some interesting movement gimmicks for the players to play around with, or possibly even the player can trigger some rendering effects that screws with people if you want to be really obnoxious. I don't know. There's lots of rooms for being creative here, but this is the essence of how to make a first-person shooter. And you notice, really, it's essentially the same thing that makes a space shooter. Kind of makes sense in a way, since they're both shooter types of games, but still. That's all for the first-person shooter. Now let's put it aside like we put aside the space shooter. Let's look at a different type of game from a similar lens. This time, we're going to look at something different, something that's not a shooter. We're going to look at a platformer. And actually, similar to a first-person shooter, we have some sort of world or area. But what we do in that area is totally different. In a platformer, this area is distinguished by having lots of, quote, platforms. May not be quite as literal as in this drawing. They might be more figurative or just generally difficult to reach areas, obstacles, things that make moving around challenging but not impossible. And we have a player who can leap huge distances, do possibly wall bounces, can maybe somehow magically dash in the air, can do basically a bunch of interesting and probably impossible in the real world motions that allows him to navigate this difficult terrain. And the fun in a platformer, unlike shooter games, comes from being able to move around like this in all these crazy different ways and reach these very difficult to reach areas in creative fashions. Essentially. Again, like everything else, it depends on the game. Some of them move to slightly different angles with it, but that's the essence of what makes a platformer. So like with everything else, we still need a render pipeline. We still need some way to display this to whoever you are, to the gamer. We also still need motion integration, because even if things aren't shooting around, we need a way to move this player around in all of his crazy ways of moving, whatever they are for this particular game. And we will still need collision detection and resolution for probably somewhat different ways. We need to still detect the player's interaction with the world to see if it's hitting something and say, oh hey, you can't phase through the world, this is solid, stop moving now. Something like that. That's probably the biggest case. If there's hazards, we need to detect if the player has hit the hazard and then it takes damage or whatever happens. Whatever bad thing the player won't enjoy happening to them will happen. And yeah, we need that. And lastly, we probably need some AI. Most platformers have some type of enemy or obstacle that can act in some active way to work against the player. Not everything has this, so this is somewhat more optional in this genre. You could make a platformer that consists entirely of a difficult to navigate world and there's no activity other than the player working against you. But it's pretty typical to at some point have some enemy type, something that chases after the player or hurts the player when they touch it, something like that. I'm sure you've seen it in all kinds of games like this. So, really, we need essentially the same set of things as we need in a space shooter or first-person shooter, even in the world of a platformer. Now, by this point, I'm sure you've noticed the pattern here. I could go on with this. I could say, hey, what if we want to make a survival horror game? Same sort of concept. We need the render pipeline to draw our survival horror world. We need motion integration so that the player can move around, and presumably the unkillable monster will also move around hunting the player. We need collision detection and resolution to know if the player hits the world so that you can, not phase through everything, and resolution for the same reason. Also determine if the player has run into the unkillable monster and needs to die. And of course, we'll need some AI so that the unkillable monster can chase after the player. So, same general rules apply even there. And if you think about it, once again, that pretty much rounds out the essential mechanics of a survival horror game. So, there you go. All those games are built around the same basic concepts. If I want to make even something as simple as Pong, what about in Pong? 3D version, the better, new and improved 3D Pong. Well, Once again, you need a render pipeline to draw the paddle and the ball, motion integration for those to move around, collision detection and resolution to determine if the ball and paddle are interacting, and some AI so that the AI paddle can try to hit it back to us and not just be basically a wall. So once again, same basic elements. These are the set of basic elements that permeate just about every game in existence. It's not an absolute law, though. Some games definitely push the boundaries of this. Like, say, a rhythm game, you still need a rhythm pipeline. You need a render pipeline in a rhythm game to just draw everything. Motion integration, you could get creative. You could work out a rhythm game where nothing ever moves. It's possible to work around that. It would help. It would give you a lot more options and creative freedom if you could have things moving around to the rhythm and challenge the player, but you don't need it. Collision detection and resolution, again, it would make your life easier. You could just say, hey, collision system, the player has pressed the key. Is whatever I'm trying to time it to in the correct position? If so, hey, the player's rhythm is correct. If not, the player's rhythm is wrong. Pretty easy to detect rhythm that way. So it definitely helps a lot. Do you need it? You could probably work around it. You could just know, hey, this is the precise exact timing. If the player hits the key between these two time boundaries, it's correct. So you could work around it, but it makes your life a lot easier. And AI, that's probably one you could just throw out entirely. You probably don't need AI in a rhythm game. But it would definitely make things interesting. I would like to see a rhythm game where there is some AI actively working against you, trying to screw up your rhythm. It would be annoying as hell, but it would definitely be interesting. But yeah, so rhythm game, pushing the boundaries a little. You could work around it, but still, basic paradigm applies. These things would still help and give you more tools of creative freedom, even in something like that. Really, probably the only game that completely doesn't need any of this is a virtual novel. Okay, you still need a render pipeline in a virtual novel, unless it's strictly text-based. You probably need some render pipeline. Beyond that, you can probably get rid of everything else. You can probably skip having anything move in your virtual novel. It'd help, it'd give you more options, but you can skip it. You can probably skip collision detection and resolution, and probably be okay. There's probably not too many things you could do with that to enhance the gameplay. There is, you could get creative with it, but you could still have a fun and interesting game without it. That's the point. And same with AI, though again, that would be very interesting. I would be very interested in a virtual novel where the AI monitors your decisions as you go through the story and then does specific things to actively work against you as the player. That would be a really interesting gimmick. Might be annoying, but it would definitely be interesting. I would like to see that. So yeah, point being, these are a common underlying fundamental set of game elements that underlie just about every type of game in existence, whether they currently exist, even if you're doing something that's completely different than anything else out there. It's like you've invented your own genre of game that doesn't really fit into any known grouping or category. Still, pretty much everything uses these, and they would probably be useful for building up whatever your new and imaginative game type is. All this is to say, no matter what type of game we end up making, all of these are the basic elements. All of these are the general big picture pieces that we need in order to make really a playable game. Something where we have the most creative freedom possible, the most ways to give the player a fun and interesting game experience. And that is why we are going to be creating these components before anything else. This is why this is the next major step in our game programming journey. We will need some form of render pipeline, motion integration, some form of collision detection and resolution, and some form of AI in order, to be able to put together whatever type of game we want to put together. And the good news is, if you do this, this gives you a lot of game creating power, because these are the basic elements of so many different types of games. If I put these together and have them really solid, I could whip together a space shooter one day, turn around and whip together a first-person shooter the next, and a platformer the next, and it wouldn't be that terrible. So it's really a good basis to build your game design off of if you build these elements. And at this point, you might have a question. You might say, hey Benny, you're saying these are common elements to just about every game out there. You're saying having a good general way of doing these would be a great boon to game design productivity. They'd allow you to make a whole lot of different games, just about any game you like. Doesn't that sound an awful lot like a game engine? And you would be correct in theory. In theory, if game engines did all these and did them excellently in a general way for every game out there, it'd be great. But historically, they don't. Historically, the game engine has provided some form of pretty much all of these, but often in a limited or specific way. In a way that's kind of half what you need, and the other half you don't. And every game engine does a different half of what you want. So, I'm going to give you a rundown of generally what you can expect in a modern game engine, like Unity or Unreal or pretty much anything else out there these days regarding these topics, because they typically do something. But this is why, in general, I'm covering how to do these from scratch, because you never know what half you're going to end up with. And honestly, in a lot of cases, you're going to end up customizing the game engine's variant of this so much by the end of your game anyways, that you pretty much do end up needing to do it from scratch. So this is why I am covering these from scratch and not just, oh hey, let's throw together a game, or use an existing game engine that already has all these implemented and moves right on with our game. That's a great idea in theory, and I hope game engines get there one day, but they're not there yet. That said, in order to not make this video any longer than it already is, I will be moving this discussion of how existing game engines handle these and the various strengths and weaknesses therein into its own special bonus video, and that will be video 11.5. But for our purposes, we're still going to need to build all these, and you'll find out setting them up on your own actually not so terrible for the most part. It's actually, for most of these, pretty straightforward if you know what you're doing. So that's what we'll be tackling next, because it's a logical step, and we pretty much need it for any type of game we're going to want to make. At least, unless you all really, really want to see a next few videos of Benny creates a virtual novel, because that's pretty much all we can create without it. So if you want to see that, we could do that, but I'm going to be implementing these so that we have more options beyond just that. So, we will be tackling that, starting with the render pipeline, in the next video. How do we do this? Will it be as terrible and complicated as it sounds? Spoiler alert, no it won't. It'll be dead simple, and you're going to love how easy it is. But how easy is it? Find out next time! I hope you enjoyed, I hope you learned, and I will see you all in the next video. As always, if you're interested in talking more with me or other like-minded people, please join the Benny Discord. It's an awesome place, and everyone is welcome. If you want to support these videos, or you just want to find out right now, you can do that by becoming a patron on Patreon. Thank you very much to all my Patreon supporters for just being awesome and making these videos possible. And a very special thank you to the people listed in the video description. You guys are the best. Thank you, and I will see you all in the next video.